Hello and welcome back to my YouTube channel, my friends. Today we are going to see how we are going to elevate a code using the Karatsuba algorithm, which enhances efficiency in multiplication problems. So what exactly is the Karatsuba algorithm? Traditional long multiplications is a method we use to multiply any two numbers manually or in computational algorithms. This involves a lot of steps like setup, multiplication, addition, carryover, and the final result completion. Say you have to multiply two very large integers like 1234 and 5678. Now we have to carry a lot of steps to get the product. This inefficiency motivates the development and use of a faster multiplication algorithm like the Karatsuba for large scale computations, as I told you. So the Karatsuba algorithm is using the divide and conquer strategy, that is the divide and conquer design technique, which is a fundamental algorithmic technique we use to solve complex problems by breaking them into smaller parts and more manageable sub-problems, as the name says, divide and conquer. So the Karatsuba algorithm is an efficient method of multiplying two large integers using a divide and conquer approach. It was developed by Anatoly Alexievich Karatsuba in 1916. That is why it has got the name by him as Karatsuba algorithm. And it is significantly used to reduce the number of individual multiplications compared to the traditional long multiplication. So if we have to take an overview of this algorithm, firstly we'll be given two n digits integers like xxx and yyyy. The Karatsuba algorithm splits the integers into each of its smaller parts, effectively dividing the problem into smaller sub-problems, that is the divide and conquer. It also leverages the idea that a large multiplication can be broken down into smaller number of multiplications using intermediate steps and combining the results we get using addition. So how exactly are we going to do this? So the first step is dividing the given two numbers. Say the two numbers are 6 and 8. So we are going to divide or split these two numbers, like say x is equal to 6 and y is equal to 8. So we are going to divide 6 into something like a into 10 power m plus b. So in this format, the two numbers 6 and 8 are going to be divided. I took 6 and 8 as an example, but these numbers usually be more than 3 digits, because that is why we are using the algorithm for large integer multiplication. So the next point is computing the three products. Computing the three products, as in we are going to multiply AC, BD, and then we are going to compute A plus B into C plus D. So all these three parameters are very much required for our next step. So yeah, the final step is computing Z0, Z1, Z2 and Z3. So the Z1 is nothing but BD, as we already computed it. Z1 is nothing but AC, that was also already computed. A part of Z2 was already computed in our previous step. So we are going to use Z2 as A plus B into C plus D minus Z0, which is already computed, and minus Z0 or Z1, which is already computed again. So after we get Z0, Z1 and Z2, we are going to compute Z3. So Z3 is going to be nothing but the product of the two numbers we always wanted, that is x into y. So Z3 or the x into y goes by the equation Z1 into 10 power 2m plus Z2 into 10 power m plus Z0. So here m is nothing but the number of digits that are involved in the multiplication of these integers. Let's say one of our number has 3 digits and the other has 4 digits. Then we are going to add 0 in the beginning of the 3-digit number so that both of them are of the same digit for the computation, which will make it easier. So if we are going to take a look at the Karatsuba algorithm in a pseudocode, here is it. Function Karatsuba x, y. Here the x, y are the parameters or the two large integers which we are going to multiply. Firstly, we are going to check if x is greater than or less than 10 or y is less than 10. So if x and y both are less than 10, then we are going to return x into y, because any number which is multiplied with a single digit can be calculated easily by the compiler and by us. The next step is n is equal to maximum of length of x, comma length of m. So n will be nothing but the maximum of the digits the two numbers compare. M is equal to CEIL of n by 2. Here we are going to split the problem into two different parts. That is why we have used n by 2. The next step is a comma b is equal to split at x comma m. So the m is the number we have got already by doing n by 2. So a comma b, at this point we are going to split again with the parameter x, that is the first digit, and m. Similarly, c comma d we are going to split at with y and m as the parameters. Then we have z0 is equal to Karatsuba of a comma c. Here we are going to recursively call the function Karatsuba again and again. So firstly we are going to pass the parameters a comma c for z0, b comma d for z1, and a plus b comma c plus d for z2, as we have earlier discussed. Later we are finally going to display or return the actual equation of z3 or xy, which is as simple as you have seen in the previous step here. That's all about the pseudocode, my friends. Thank you. I'll be back with more such content for y'all. Until then, see you all.